let's do a quick review of what we know about type checking in the context of inheritance hierarchies, and we'll also talk about a new handy tool known as casting. So what I'd like you to do to set the stage here is consider this code and think about, for each line of code, does that line of code cause a compilation error? And two, does it cause, what method actually gets executed? So if we think about how dynamic method selection works, which one actually gets run, which method in the hierarchy? So I've already done the first two lines for you. I have that the vengeful slist, VSL is a vengeful slist variable. It has static type vengeful slist, and it points at a vengeful slist object. SL, by contrast, is an slist static typed variable, and it still points at a vengeful slist because, hey, that's what it does. So think about these remaining lines of code, and I will let you pause the video and ponder that. All right, so let's consider first these two lines of code. I'm going to put them in isolation. In this case, do these work? Yes. S-lists have certainly an add last and a remove last method, and which one gets called? Well, first when we consider the add last call, we consider the dynamic type. What's the dynamic type of SL? Well, it's vengeful slist. So we'll try and call the add last method of vengeful slist. However, vengeful slist did not actually implement that. It didn't override it. So it'll just go one step higher in the hierarchy, and it will use the slist class add last method. Dynamic method selection then comes around to remove last and says, hey, you know what? I'm always going to decide if a method is overridden, I'm going to pick based on the runtime type of the variable. And in this case, the vengeful slist class does have a remove last method. We wrote it in one of the first videos of the sequence, and so it runs the vengeful slist. Okay? So in other words, we already knew, just a little review, that's how dynamic method selection behaves. Now how about this next line of code, sl.print lost items? Now here you might think, well, I mean, it is a vengeful slist and it has a print lost items, so maybe dynamic method selection should be doing something, but there's an issue. And that's that the compiler is very conservative with type checking. So it actually checks and it says, you know what, S-lists don't actually have a print lost items variable. And the rule of thumb, the very simple rule, is that the compiler decides whether or not something is valid based only on the compile time type of the variable. Remember, that's also called the static type. So in this case, because the S-list, the SL variable has static type S-list, we cannot call print lost items, even though this underlying object here, it has dynamic type vengeful S-list and does have a print lost items method, it cannot run. And actually the same thing happens on this next line. Whenever I try and assign the address of this vengeful S-list to a new variable, not pictured here because it crashes, but if I actually created this variable, VSL2, I could not actually copy the contents from this memory box S-list to another vengeful S-list box, because the compiler will say, cannot take an S-list and copy its address to vengeful S-list, even though you and I both know that the runtime type is vengeful S-list. So why is that? Like, what's the idea here? Well, basically, the compiler is only going to allow method calls and assignments based on compile time types, and it's just very nervous. It doesn't know what's going to happen at runtime, and if it did actually try and, use the intuition we use to say this should be fine, it would have to basically mentally execute the code in advance. And that would mean the compiler would have to be considerably more sophisticated, and in fact could run into trouble where a bug in the code might mean the code never compiles. Okay, so kind of a subtle issue, but think about it this way. Just the compiler is super, super, super conservative, and it will only allow things based strictly on the compile time types that you tell it. Okay. Now this last little bit here, whenever we said we could not do this assignment, we can actually generalize that a bit and say that expressions have compile time types. And one of the jobs of the compiler is to make sure that all the expressions compile time types line up. And so we're not going to go through the whole type system in Java because it's too complicated, but essentially, well, I'll give a couple examples. First, if we have an instantiation using the new keyword, this has some specified compile time type. So if I say new vengeful S-list, you can think of this whole expression as having a compile time type, and its type is vengeful S-list. And so when Java is trying to decide, is this assignment allowed, it says here, if this is a vengeful S-list, and this is an S-list, it says, is a vengeful S-list an S-list? And it has this diagram. I can look and say, yes, indeed, a vengeful S-list is a subclass of S-list, so I'm going to allow this assignment. So it checks the right-hand side, which I will have on the slides as just RHS. It checks the right-hand side, and it makes sure that this type is compatible with the left-hand side of the expression. Now, by contrast, If we create an S-list, right, this has static type S-list, and this has static type vengeful S-list, and it says, is an S-list a vengeful S-list? Well, sometimes, but not always. And so the compiler plays it very safe, and it says this is not allowed, and will crash. Now, we can have other types of expressions. So when you add numbers, that's an expression. When you do new, that's an expression. And maybe one of the most interesting things is a method call. So anytime we call a method, say maxdog, the expression here, or actually I'll say here, maybe this example is a good place to start. I have two poodles, Frank and Frank Jr. And I say dog, larger dog equals maxdog, Frank Jr. So the question is, what is the compile time type, aka the static type of the maxdog call? Well, it's whatever you declared it to be. So I said it's public dog. Therefore, the compile time type of any expression that uses maxdog, or sorry, any call to maxdog will be dog. Okay? And so in this case, if we say dog, larger dog equals maxdog, Frank and Frank Jr., it says, okay, this is a dog. Is a dog a dog? Yes. Okay, so that line's fine. But then when it gets to this bottom line, when it does maxdog, Frank and Frank Jr., even though the runtime type of these two objects is poodle, we cannot assign the result to a poodle variable. Why? Well, because the compiler says the static type of the maxdog call is dog, right? The compile time type is whatever you specified. And therefore, it cannot assign that to a poodle variable because it says, is a dog a poodle? Well, sometimes, but not always, so I won't allow it. Okay? Now there is sometimes you actually want this to work. And casting is something we're going to do rarely. And in fact, we already did in the ArrayDeck class in Project 1A. But this general tool of casting works like so. So I have an expression, whatever it may be. It could be a method call. It could be an instantiation. It could be an arithmetic operation. It could be some giant, blob of stuff. There's a special syntax where you can say to the compiler, please consider this expression to have this certain compile time type. So to do that, this expression has compile time type dog. Why? Because it's public dog maxdog. And we can say, please treat this like a poodle. Okay? To do that, we put in parentheses the name of the class that we want it to treat it like. And in that case, the compiler will now, in terms of its type checking, the first thing the compiler does is it makes sure everything's good. For that purpose, it will use this as the type. So for example, this code right here that didn't work so well, if we just add poodle in parentheses here, the compiler will say, okay, the programmer has specified that the output of the maxdog here is no longer static type dog, it is in fact type poodle. Is a poodle? Yes, therefore we're good. Now that approach, while useful, can sometimes run you into trouble. Because basically what you're doing is tricking the compiler. You're telling the compiler, please don't do your job. Don't be, such a wimp. Trust me. So it's a powerful but dangerous tool. You should use it sparingly. And it basically tells Java, treat this the way I want you to treat it. So let's suppose, this is where you can run into trouble, we have a poodle variable and a Malamute variable. Now both of these are dogs, so we can pass them to the maxdog method. And this will return a object of type dog, and we can cast it to poodle. Well, the compiler, ordinarily, if we didn't have poodle here, would say, no. This is a dog, and I don't know what kind of dog this expression's going to get back. But we can say, no, trust me, it's going to be a poodle, everything's going to be cool. But in this case, actually the result is Frank Sr. And so when we try and cast that Malamute that comes back as a poodle, then at runtime, we run into trouble. So in particular, if you run it, it will say class cast exception, and the code crashes at runtime. So we said earlier, actually in the very first lecture, that one of the great things about Java is it does this type checking, meaning that nobody on the other end should run into type errors. However, if you decide to use casting, that is no longer true. So in that sense, it is dangerous, but sometimes you'll find it quite handy.